Hey everyone.
Hello everyone.
Good morning.
Hello. Hi Fabio, hi Natale, how are you doing?
Morning, guys.
And welcome to our guests, Christophe and Sebastian.
Hi, folks.
Hello.
Good morning.
Hello
Good
everyone.
morning. All good, all good. Welcome to OpenShift TV Coffee Break, our other episode today. Today I'm here with Andrea, Fabio, Christophe, Sebi. The hot topic of today, Andrea, is?
Hi. Hello everyone.
The hot topic of today is Java operator.
Java
operator. Yes.
We have today Christophe and Sebastian who will talk about the Java operator. And without further ado, I'd like them to introduce themselves.
All right. Shall I start or?
Sure.
Please,
Start.
Christophe.
Yep.
You go.
So hi everyone. I'm a software engineer at Red Hat, and I'm one of the lead developers on the Java Operator SDK and its Quarkus extension. And I think that's what we'll be discussing today. So I hope we'll have an informative session and for you folks, and we'll have good questions and good interaction.
And I'm Sebastian Blanc. I work for Red Hat as well. I'm a developer advocate. I work together with Natale over there. And the rest of the team, we have an awesome team. What we do, we make developers happy. We show them cool stuff. Honestly, when I discovered the Java Operator SDK, I really felt in love. And it's such a great thing because you can combine it with Quarkus, of course, but I'm sure Christophe will show you that. I have also things to show if needed. So
I'm really looking forward to hearing it.
Yeah, and I'm really excited about it though.
As our tradition, we'll have our sip of coffee today.
Exactly. Yeah, of course. And thank you for the invitation. I'm really happy to be on OpenShift TV for real.
Well, a question first of all. We've been talking about operators for a while and different ways of building, creating operators and coding them. Why Java? Is Java suitable for that?
That's a good question. And to be honest, until maybe a couple of years back, maybe that question would have been quite different. But today the landscape has changed. First of all, Java, we have to realize that Java is one of the most used languages in enterprise development. So it makes sense if you follow the DevOps philosophy that you would like to have your application, which might be written in Java, to use the same language over the whole life cycle from development to operation. So from that perspective, it would make sense to use Java for operators. That said, traditionally speaking, Java was for a long time not very well suited to live in containers because Java has been optimized over its long lifetime for long-running processes running on big, huge servers, and it was basically used to take a lot of space, the whole space for itself. And in containers, that doesn't play very well. But lots of improvements have been made on the virtual machine on that front. So it's a lot more suitable. And then a couple of years back, Quarkus happened as well. Quarkus, for people who might not be aware of it, is a Java framework developed by Red Hat, which allows, among other things, because personally speaking, I think the best thing about Quarkus is not the native compilation, but the developer experience. But it allows, among other things, an easier path towards native compilation of Java code. And even though Java has improved to live in containers, it still makes sense to sometimes compile down to native binaries to squeeze out every performance possible. And so that makes a lot of sense, in particular with respect to starting time and memory usage and things like that. So the way I see it is that, sure, Go has traditionally been the language to go without bad pun, but it's the go-to language when you program Kubernetes, because the ecosystem is written in Go, and a lot of libraries are in Go. So it made sense, but we feel that the time for Java on Kubernetes and in operators has come, and we'll see why in greater details probably later.
So in a sense, if you have a team that has chosen Java as their language of choice to build their applications there and put them in containers, the fact that they can also build the operator that takes care of the service that these pods are providing makes it easier for the people with the same skills that they used to build the applications also to build the operator that maintains, configures, and keeps the service up.
Yeah, definitely. Yeah, that's exactly the idea. Why? I mean, Go is not a difficult language to learn. You can ramp up pretty easily. But if you already have the expertise in Java inside your company, why spend that time retrain your employees when you could do it in Java? And if you need to hire folks also, I mean, Go is I guess more and more people are fluent in Go, but there's a wealth of Java developers out there as well. So we can leverage that pool of knowledge.
Yeah.
It's all about giving developers freedom and choice.
Yeah.
Yeah, and I would add as well, when it comes to Java, what is really important when you create an operator is to have a good library, a good Kubernetes client. Okay, Go has an excellent one, and the fact is that in the Java world we have an awesome library, the Fabricate Kubernetes client, which is awesome, so easy to understand. So that really helps when you are already a Java developer and you need to start talking with your cluster, creating pods programmatically, listening to events. We have already an awesome library that is there, ready to use, and that's a really important piece also that make it easier for us to use Java to create operators.
Yeah, Fabio Natale, do you have any comments, questions?
Yeah, I was thinking about an application life cycle. If you are building a complex application or a variety of applications that need to work together, having Java or having the capability to leverage Java to build the operator that could manage that application/applications can reduce the effort in terms of governance, also from the developer perspective, but also ops perspective.
And also, I would say, if I may add, the familiarity of the developers with their IDE, their debugging techniques, that they can use both for the application and for the operator.
Yeah, no, exactly, and we have a lot of Java teams over there in the enterprise world, and we are also seeing this whole DevOps movement where developers also wants to get included in the ops operation. And yeah, when you have a Java team now, if they need to create an operator, they can also do it. So yeah.
Yeah,
Okay.
because I mean, even though Go is easy to learn, I mean, if you have a language that I mean, any programmer will tell you they have preference for languages, and when you are comfortable with the language, you're much more productive and generally happy.
Christophe, Sebastian, what are you going to show us today?
We can show to get started with the operator SDK. Maybe talk a little bit about the architecture or what makes the Java for operators such an interesting proposition at this point in time. Because as Sebastian was saying, we've had in the Java world, we've had quite a compelling client for a bit of time, but writing operators is a lot more than just connecting to the cluster, right? So if you take the analogy with what happens in the Go world, the equivalent of the Fabricate Kubernetes client would be client Go. And so if you were to write an operator using only client Go, it would be difficult. I mean, for that matter, you still can you can create operators with pretty much any language, as long as you can do REST calls on the Kubernetes server. But the availability of frameworks to help you in your work is really a big plus. And what was missing in the Java world, at least until recently, was the availability of such frameworks, and that's where the Java Operator SDK comes into play, which would be kind of the Java equivalent, or at least that's what we're aiming, the Java equivalent of controller runtime, but for Java. And
Okay.
so maybe I should show
yes. Let's start with how you build an operator in Java.
Yep. So the good thing is that maybe I should share my screen. And can everyone see my screen okay? Maybe I should increase the font.
No?
Not yet.
Because I see it.
Yeah, I think it's available.
maybe if you could increase the font a little bit.
Yeah, again. Okay, is
It's
it
a good
better
screen.
now? Maybe I should switch to a different scheme. Can people see okay? But
please let us know in the chat if you guys can see it okay.
The idea is that now it's possible to scaffold an operator using the operator SDK command line interface that is familiar with Go developers. So recently we've been adding a plugin to the operator SDK command that allows you to scaffold a Java operator, and that's done using the traditional operator init operator SDK init command. And as you can see, we specify a plugin that's named Quarkus because it will use the Java operator SDK, but consume via its Quarkus extension. We'll talk a little bit about the details of how that goes. And we provide a domain, which is basically scoping for our custom resource and things like that, and a project name, and that scaffolds a nice project. So if we look at what got generated, you will see that that is a typical Java, Maven Java project. You will see that there's no Java code generated, just a POM, XML, and a couple of other files that we'll use later. But at this point in time, there's no Java code. But still, we can start the Quarkus dev mode because the POM file includes, maybe I should show that, includes the Quarkus operator extension, which is defined here. It's called Quarkus Operator SDK, and we have all the dependencies nicely packaged using a BOM file. Oops. So that allows us to start the Quarkus dev mode. So for people who might not be familiar with Quarkus, it provides a really great development mode, which allows you to live code, kind of live code your applications. And so we start our application, even though we don't have any Java code in our scaffolded project, we still have the Quarkus extension started, and it tells us that we have no Reconciler implementation. So basically, it's not doing anything because we haven't written any code So that's understandable. Maybe I will split this window. Oops. And the way we do we create a reconciler using maybe I will do that like this rather. That will be better. The way we create a reconciler using the scaffolding options of operator SDK is that we basically tell the operator SDK command to create an API, because if you know about operators, I assume that most people are familiar with the concepts, right? So an operator is an API that is materialized by a CRD, custom resource definition, and its instances, the custom resources, and a controller that encapsulates the logic and the knowledge associated with dealing with those. And so in that sense, creating what's called an API using the operator SDK, that makes sense. So the way we do that is we call the create API command, and we specify a version for our API and a name, which is in Kubernetes parlance, it's called a kind, which will be associated with our custom resource. And so that creates more files. And that's weird. Oh, yeah. And so you can see that I don't know if you've noticed that, but the operator SDK has restarted the application automatically because it realized that new code that has been added. And in fact, it uses our package name that we specified earlier, and it created a couple of classes, which we will look at. And if we look at what's going on the Quarkus side of things, it restarted automatically our application. That's what I meant by live coding. You can develop your operator live. You go to your IDE and you keep the Quarkus dev mode running, and as you change your code, then the Quarkus extension takes care of doing things for you. And in particular, as you can see here, as after it restarted, it registered the classes that we've created automatically for reflection, and that's useful for native compilation. If you were not using the Quarkus extension, then you would have to do things manually to be able to natively compile your operator. It also detected that you now have added what we call a reconciler in the Java operator world. We'll talk a little. We're going to see what it is shortly, rather. And it generated, which is really interesting, it generated a custom resource definition based on the Java classes that we've added. So if you've ever had the pleasure or displeasure to write a custom resource definition by hand, you'll be pretty happy to know that it can be automatically generated from your Java code. And obviously right now it's not, if we take a look at what got generated, it's pretty empty because our classes are empty themselves. But it's still great that it does it automatically for us. And what's more important is that it will keep the CRD in sync with your Java code. Another interesting thing, actually it didn't get done in that part, because we can see here and that's actually something we will change. The default will change because it makes more sense to do it the reverse way. But right now it's telling us that our CRD has not been deployed on the cluster.
I was about to ask you that, Christophe, because I said, hey, you didn't change the property. Maybe you changed the default.
Yeah.
Okay.
But we will change the default because for the dev mode, it makes sense that because anyway, that the property that Sebastian is talking about, there's a property that we can activate if we look at the application.properties. There's a property here called quarkus.operator-sdk.crd.apply, and it's set to false. And that property is used to actually tell the Quarkus extension to automatically apply while you are running in dev mode, the Quarkus dev mode, because you don't want to do that in production. But then again, you're not really changing your CRD in production either. But what the Quarkus extension will do now, after I change that file, is that it will take the CRD that got generated and automatically apply it to the cluster. So that's one other step that you don't need to do manually, because previously, if you work in Go, well, for one, I mean, you would have to manually apply your cluster, your CRD to the cluster by doing kubectl apply, etc.
And the huge thing is that if you update your Java class that represent this CRD, it will just generate again the CRD on the fly and reapply it. So you can just really focus on your code. And you don't care about the CRD. It will be updated on your cluster.
So from the perspective of the Java developer, they see the CRD as a Java object that they define define within their code.
I'm sure Christophe will show what has been generated, the Java class.
Oh yeah, I'm not sure what's going on now, but there was a problem. But
that's the beauty of live demos.
Oh yeah.
But let's see, where is it? Well, I guess I don't see it in the logs, but oh yeah, it's here. It applied the CRD that got generated automatically. So let's look at the code maybe. Let's look at, let's start with the reconciler. Can everyone see in the screen okay?
Yep.
Yes.
Yep.
Yes.
So in the Java operator SDK world, we use the concept of reconciler, which is an interface. If we look at it, it's pretty simple. It has two methods, reconcile and cleanup. And cleanup is not needed is not necessarily needed most of the time. So the code that got generated, it used the name of the kind that we specified to the operator SDK command to basically generate a whole bunch of classes that are named with exposed app, which is the name of the application the operator will be looking at today. And as you can see, the reconciler interface is parameterized with the exposed app class, which is our custom resource, which is the class that represents our custom resource. And typically in Java operator project, that's all that will be needed. Usually we don't touch the custom resource class itself. It extends the Fabricate client, Kubernetes client custom resource class that provides a whole bunch of interesting support for custom resources. And it is annotated with the version and the group name that we specified when we created our API using the operator SDK command. Interestingly, as well, it's parameterized. The class itself is parameterized with two other classes, because we feel the SDK and the Fabricate client, at least for the custom resource support, kind of enforces the best practice to split the desired state, which is represented by the spec, and the actual state, which is represented by the status. So if you think about what a custom resource is that you have the desired state of the cluster, which is under the control of the user, and Kubernetes, the best practices for Kubernetes resources or development is to put that under a spec field in your Kubernetes, in your custom resource, sorry. And that part is under the control of the user, that represents the desired state that the operator is trying to create on the cluster. So our operator will take the desired state, look at the state of the cluster, and try to reconcile both states, and see, okay, what is different between the desired state as opposed to what I can observe from the state of the cluster. And then you have the status part of things that is where the controller associated with your operator can let the user know what's going on, and basically are different. What are the differences between the desired state and the actual state of the cluster? So if we look at those classes right now, they are empty because they just got generated. And then let's go back to our reconciler. So we have the reconcile method, and we can see also that we get the Kubernetes client from the Fabricate. Kubernetes client is injected automatically in our code. And to write an operator using the Java operator SDK, that's pretty much all there is to do. You don't need to worry about watchers or informers if you're familiar with writing operators in Go. I mean, you still need to be cognizant of those concepts, but you don't have to wire these manually yourself. And so the SDK, the Java operator SDK, as soon as you have a reconciler implementation going, it will take care of calling your reconcile method anytime there's a change that applies to your registered custom resource. So if I create a custom resource, maybe I should do that here. And I do system. So I'll just, here to demonstrate this idea, I'll just create a custom resource with just a name. I mean, right now it's empty, or maybe I will add the field already, so that will be. I'll just add a field that will be a string, and it will be called image ref. And I create a getter and setter for it. And supposedly our Quarkus application should get restarted.
And while it restarts, so
yep.
When you implement your methods, I guess what all you have to know from a Java perspective, from a developer perspective, is how to invoke, for example, Kubernetes APIs through the Kubernetes client. So understand what the Kubernetes client can offer. And that's probably what they need. But and correct me if I'm wrong, that doesn't limit you. You may, in your methods, interact with the database and set up a database using what you know about Java APIs to do that.
Yeah, you do whatever you want. The first sample that Christophe wrote for the Quarkus extension is a joke operator. So it gets a request from a joke API and it just retrieves you the joke, because it's talking to an API. Maybe later on, if we have, still have some time, I will show what I've been playing with. I'm interacting with Git, with a Git app, for instance. So you do what? That's the beauty of operators. You do whatever you want in this method.
So yes, as you can see, our CRD got added. Got modified. I added a string field to my spec class, and the CRD got regenerated, and it got reapplied to the client to the cluster. So if I look at my it's here on the cluster, and if I there's no custom resource now, but let's apply one. Yeah, sorry.
Did you plan to generate also maybe a sample custom resource in the SDK? Because I know for the operator SDK, it also generates a sample CR based on your CRD. Now we have to do it manually. Is that something that you plan to do?
That's a good idea. I didn't think about that, but we could.
Okay,
I will probably do that.
I will open a ticket then.
Yes, please. So we will create a custom resource here. So let's call that. Sorry, it's not XML. And I will just paste. So if we look at that that custom resource, it basically is it specified the API version that we specified and the kind that we specified for our API. We just specify a name for our custom resource, and in this use case, but I guess we won't get into the details. But the use case here is to expose an application based on simply an image ref. So if you want to be able to access your application that's deployed on the cluster, outside the cluster, you will need to add a deployment service and an ingress or a route on OpenShift. And so this simple operator, what it does is that it creates all of that for you simply based on the image ref that you specify it. But I don't know that we will have time to go into all those all the details there. But let's apply that custom resource on the cluster and see what happens.
Yeah, and while it's getting applied, I see that Andrea, you put it in the chat. There's the link to the Kubernetes client, the Fabricate Kubernetes client. If you go on the repo, you have a cheat sheet showing you all the common stuff that you would like to do, like creating a deployment, creating a service. And there's also really useful comparison between kubectl commands and how you would do that with the Kubernetes client. So for me, it's really the Bible. Every time that I play with this library, I go there on this documentation. It's really useful.
Yeah, and so as you could see, maybe we just added the name output of the name of the custom resource, and it got output in the logs of our operator. But now, if we want to do more complicated things, you might be wondering also why we return. We have a specific return type that basically is telling the operator SDK what to do after the reconcile method is done. In this case, we return no update because nothing happened. But you can also modify the status, and you could say maybe we'll change we'll add the status here, and just call it status. And we just want to put the status of our resource and just update the status to add the name. That's pretty stupid. I mean, that's not very very useful, but just to show what happens. And we return. So in this case, what I've been doing here is that I've been updating the status of my custom resource and telling the SDK that I want the status of my resource to be applied. That I've changed the status, and so it needs to apply my custom resource any changes that might have happened to the cluster. And what happened? Yeah, it's because since it's live coding, sometimes it gets restarted at the wrong time. But if I restart it,
so it's up to the controller when they receive the status to then update the CRD. You don't have to do it yourself.
Yeah, you don't have to do it yourself, exactly. Yeah. So what did I do? Oh yeah. So as you can see, it's really live coding because I made a mistake, and I'm still making a mistake. What's going on? Yeah, because I'm not calling the proper node. And okay, that should work. And that actually shows something that, well, it got restarted. But that showed something that I didn't talk about, is that, as you can see here, it's, well, not here, but somewhere, yeah, here. So my code wasn't working, and the SDK has automatic retry. And so it retried until it basically exhausted. You can configure I'm not sure what happened here, but you can configure the retry policy for your operator. So if an exception occurs during your operator, it will automatically try to reapply to try the operation again until it either succeeds or it decides that there's no point in retrying again. So if you look at our custom resource now, you can see that here the status has indeed been updated, and if you recall, the operator started, got restarted automatically for me and I added a field to my status, to my custom resource, and the CRD got automatically reapplied, generated and reapplied. I didn't have to worry about it. I could focus really on my Java code, and for me that's a great experience, because I was a little flustered with my code, and that wasn't quite working, and I didn't have to worry about, okay, what's going on with my CRD? Did I forget to reapply it? Did I regenerate it? No, I just needed to focus on what was wrong with it. So I think it's a great experience for Java developer and for any kind of
Another quick
developer,
question
really.
on the SDK. So we've been seeing how from scratch use the SDK to build the whole scaffolding and then try and fill in the blanks and create an operator. Does the SDK also create some sort of test harness or some scaffolding for testing? Or
we have a JUnit extension to write tests. It's indeed one of the weak points at the moment, probably, with the SDK is the testing support, but we are working on it. And like I said, we have the JUnit extension that allows you to interact with the cluster more easily. But we could definitely improve things, I think. It's just a matter of time, because we've been working a lot on the features, and
sure.
Yeah, and people can contribute, of course. It's all open source. So.
Also, yeah, everything is open source, definitely as well. So yeah, that's the gist of it. I probably won't go into more details unless people are interested in seeing more details right now. But maybe
Fabio, any more questions for Christophe?
I would like to leave the stage to Sebi, and then yes, I do have some question, or let's see if Sebi will answer my question without.
And that will pop up some questions, because I want to show an example, sample operator,
please,
and Christophe is helping me on this as well. But I started. So, do we see my screen? No, can you put my?
Do you want me to?
Yes. Yeah, put my screen. I will show you some stuff. So, as I said, I fell in love with this SDK, and Christophe helped me a lot, explaining me the stuff and everything. And then you have to create your operator. Okay, so I had no idea. I did some stupid operators. I even did a Quake-free operator. For another show, maybe. But anyway, I came to the idea of a more serious operator, and you probably know about GitOps. In this show, you had a lot of shows about GitOps, Argo CD. So basically, GitOps, what is it? The source of truth is your Git repo, and you have an operator that is scanning your GitHub repo and applies the resources from there. I say, hey, we have a good Kubernetes client. We have a good library to play with Git in Java called JGit. Okay, let's try to make my own GitOps operator, a really simple one. And so I exactly did what Christophe did. I launched a new project with the SDK, and I started writing my spec object. Okay, so what do I want? I want a repo. Okay, pointing to a repo. I want a reference, maybe main or any branch. I want to specify on which namespace of my cluster it will be applied, those resources. And maybe I have a subdir in my repo where my YAMLs are located, for instance. Okay, so I just keep it simple this way. And you create this, and of course the whole CRD gets generated. And okay, and then you have to write the code itself. Okay, so here, don't be afraid. It's a bit.
And before you continue, I wanted to interrupt you. I see that we have the IntelliJ fans on one side and the VS Code fans on the other side, and I think it's worth reminding that there are Quarkus extensions for VS Code. I'm gonna put the link in the that Christophe gave me for VS Code as well.
That's true. And let me see. I'm missing a lot of code here. Let me see. Resources. Oh no, I'm not missing any code because I mix up with another operator. So what I do is really messy, and Christophe have found a solution for me to remove, because I need to scan every 10 seconds, for instance, the repo. So I'm using a library called Quartz. I should not use that. And Christophe showed me, he opened a PR to remove that part, because out of the box, the operator, the SDK can handle that. But basically, my reconcile, what happens, let's just here go to the job. Basically, let me see. Let me show you the interesting part. Yeah, that's the interesting part. That is where, basically, what I do here, I use this JGit library. I just clone the repo, okay? And if it's not new, I set the path, etc. And then I call create resources, okay? And if we go there, create resources, come on. Up. Look at this. Here you have the beauty. Come on. You have the beauty of the Kubernetes client, okay? Here I have the content of my file, okay? And I just do client load the input stream to my file in the namespace that I specified, and I do a create or replace. And that's it. That's the only thing I need to do. There's some methods like is it YAML file or stuff like that. But the core of the operator is really cloning the repo and applying the resources. That's what we really want to do. Of course, later on, we could make it better. And then how does my custom resource look like? So it's something like this. So I call it GitHub's repo. Okay, you give it a name, you pass a repo, a reference, a YAML, a resource dir, and the namespace. Okay, and that's it. And then if you get your so if I go back here, I get this operator running in dev mode. Okay, I have a Minikube running. Okay, he applied automatically the CRD, and I can start doing stuff like kubectl apply -f and cr sample. Okay, and if the demo gods are on my side, and it's been a while since there we go. Look at this. So what you can see here, a lot of stuff is getting created. Let's take a quick look at my repo that he cloned. So basically, he cloned this repo. He went into this folder, and he found deployment here, a simple deployment with 2 replicas, my boot. And let me see, the other deployment is my boot 1 with 3 replicas. So we should have 5 stuff created, and look at this, we got it created. Okay, it's taking some time because there we go. And let's imagine that I let me see if I open a new one. I hope I have it cloned not so far. My operator tests. No, don't I have it here to GitHub? I don't have it here, but you know what? Let's do it crazy way. Let's just change it here. Oh. Let me go here. Let me go here, and let's go to this YAML, for instance. So let me go to this deployment, and let me edit this. Editing YAML on GitHub live. I never did that, I think. And let's go
crazy.
Let's go for 4 replicas, because why not? Okay, I commit this. Okay, it's committed. And if we come back here, we should see, look at this. It's already getting created. So it's already applied. So I really have a GitOps, a really simple GitOps operator. And one interesting stuff is what happens, and maybe that's just for you, Christophe, you can take it over. What happens if I do kubectl delete? How do I call it? Simple GitOps repo. And let me see, because what you want, if you delete this, there is this. Okay, so I can do a kubectl GitHub repo. I know it's not that fantastic, but I always love it. Kubectl delete GitOps repo, my repo. Okay. Deleted what you really want to do, and I'm not sure it's working in this version. You want also probably that your deployments get deleted. Every resource that has been applied, you also want it to be deleted. Okay, and also dependent resources. Okay, maybe you're creating I don't know, a deployment that spawns another deployment, and when you destroy it, you destroy your CR. You want it's cascading, deleting stuff. So maybe you can take it over from there, Christophe, and speaking a bit about dependent resources.
Yeah,
and
sure.
I will share in the you can, and I will share in the private the link to this small project that I did.
And also, I think Christophe wanted to show some more.
Yeah, that's actually what I wanted to show. Yeah. So yeah, for the scenario that Sebastian was talking about, the obvious solution is to set the owner reference on the dependent resources, because basically you have your primary custom resource or primary resource, which is the one that your operator takes care of, and then to reconcile to create the desired state represented by that resource, sometimes you need to create other Kubernetes resources, right? Or even external resources. And those are called dependent or secondary resources. And in the case of Kubernetes dependent resources, you can control the life cycle of those dependents by setting what's called the owner reference. And you basically tell the dependents that their owner is your primary custom resource, and when you do that primary resource, then it will automatically delete all the other resources. So maybe if I share my screen again.
Yeah, go on, share your screen, and I can share some links on the other side.
So we're gonna switch from Sebi to Christophe.
Okay, can you see? You can see
your screen.
Yeah.
So I'm not sure what's going on here. It's the same operator that I showed earlier, but in a more slightly more advanced state. So it's the exposed app reconciler, and we have a whole bunch of other stuff where it's doing the whole thing that we talked about, creating the deployment and service, etc. And in more recent version, and it's actually not released yet, but when you create your reconciler, as Sebi was showing, you can annotate your reconciler with a controller configuration that allows you to specify several things. In particular, which are the namespaces that your controller will watch. In this case, I tell that my reconciler or controller will only watch the namespace in which it's deployed, but you can also tell it to watch all the namespaces, or only limit your operator to only watch a given set of namespaces. So if you only want to watch like 3 namespaces, you can specify them. We can override its name, which isn't that important here, but what I want to talk about here is the dependence concept. So we talked about dependent resources, right? And in recent version of the SDK, we have a mode that we call manage dependent resources, where we can extract. Typically, you would typically reconcile the state of all your dependent resources in the reconcile method. But with that new declarative way of doing it, we say, okay, we have my primary custom resource exposed app needs to deal with a deployment, a service, and an ingress. So I will create what we call a dependent resource implementation to deal with each of those classes. And if I look at my deployment dependent resource, so that's the class that will deal with the deployment associated with my exposed app custom resource. And I just need to implement only a couple of things. In this case, two things. First, I need to specify that, I extend an SDK class called Kubernetes dependent resource, and that gives me already quite a bit. And I tell it that, okay, my this dependent is of type deployment here, so it's a deployment coming from the Fabricate Kubernetes model, and that the associated primary resource type is exposed app, and I specify that this deployment, this dependent resource will be in charge of creating deployments, and Matcher will talk a little bit later. And the only thing I need to implement in this case, because I reuse the behavior provided by the Kubernetes dependent resource, is to specify what my desired deployment looks like based on the state of the primary resource. And that's pretty much all I need to do. So in this case, I won't go into all the details, but I basically extract the image ref from the spec of my primary custom resource, and I create a container for my deployment. So, I actually create a deployment builder using the Fabricate Kubernetes client fluent interfaces. So it's pretty nice because it reads quite fluently, because I say, okay, build me a deployment with metadata that I pass, and with a new spec that uses a new selector with those labels, match labels, and using that template with the same labels, and I want to add a new container with the name and the image that I specified. Well, in this case, we do a little bit more because I added some support for environment variables, but we don't care about that here. And then I create my container with a new port and HTTP. In this case, it's hard-coded to expose 8080, but we could expose that to our CRD if we wanted to. And that's it. I just specify. So the idea here is very simple. You using the desired, you get the primary represents the desired state, and extract that state, and you build what your deployment in this case, but what your dependent resource should look like. And then the SDK takes care of doing it, applying, doing what's needed on the cluster. So that basically means, in this case, we only say that we just want to create that deployment. We never want to update it in this case, so we're only implementing the creator method interface. But in this case, it means that the SDK will look at each time there's a reconciliation that happens. It will look at is there a deployment that basically matches the desired state? If not, it will create it automatically for me. And the only thing I needed to do is define what the desired deployment looks like.
Christophe, a question. So potentially these dependent resources could be defined by other CRDs that are monitored by other operators that will get triggered. Is that a fair statement?
Yeah, it is a fair statement. And that takes care of wiring things for you automatically, because basically when you declare a dependent resource of type Kubernetes dependent resource, what happens in the background is that you will get an informer that watches those resources automatically. But those dependent, they don't need to be Kubernetes dependents. And we have samples that actually show a MySQL cluster that is considered as a dependent for a primary resource. And we provision automatically, that operator provision a MySQL database based on the state of the primary custom resource and things like that. So it's quite powerful. And
if I can ask, we are running up to the hour, but just because it's very interesting topics that in the GitOps domain, the Java operator and their capabilities. How do you see the interaction between Argo CD, obviously, and what you show in terms of controlling a complex deployment of workflow? I don't know if my question is clear. So, because you mentioned that obviously you can control some requirements regarding your application. Similar things would be done also with Argo CD, with the sync away, sync hooks. And just in your point of view, how do you see this? I'm not saying overlapping, but in terms of chain responsibilities.
Well, for one thing, I'm not too familiar with Argo CD, so I might not be the best person to answer that question. But the way I see it is that operators, and I think one of your previous guests was saying that it basically encapsulates human knowledge of operating a complex application into code. And that's what operators are best suited for. I mean, because operators are quite a hot topic at the moment, and many and maybe folks might be excited about writing operators for this or that, and sometimes an operator might not be the best option. So the first question that you have to ask yourself is, do I need an operator for this particular use case? In some cases, you don't. So, and probably in this, in the sample I just showed, you probably don't need an operator for that. That's true. It's just a way to show, but the added value for operators is that they can react dynamically to what's going on the cluster. If you do, because for example, if the only thing that you want to do is deploy an application, maybe an Helm chart is better suited for that use case. Whereas an operator will be much more dynamic because it can react to what's going on the cluster and adapt. So that's maybe that's my answer. I am not sure if
no, definitely yes, because the capability to react to events which are from Kubernetes and not only from Kubernetes, if I read well.
That's also the thing, because the operator can deal with, and we have support for that, deal with resources that are external to the cluster. And I think that's also where
that's a great thing,
the added value is as well.
And I think that's all we have time for today. And I wanted to thank you guys, Sebi, Christophe, for joining us. Hopefully, we will have other occasions to continue this conversation again at OpenShift TV at Coffee Break. And I wanted to remind everybody of the next. What do we have next, Fabio? By the way, it's on the 9th, I think.
We should probably have again Battaglia.
Talking about the Hackfest.
The Hackfest and Hackathon community. So we had him 2 weeks ago, if I'm not wrong. So we are going to talk about the community now, something more than just the Hackfest.
And thank you all for joining us today. Hopefully see you again in the future.
Thank you so much, everyone.
Hopefully that was helpful.